So a little point here about the data science process so that everyone knows at what point evaluation is performed. First, we go through business understanding. So a little example. Let's say that we want to talk about fraud detection in a bank. We are interested in training a model that can automatically flag when a credit card transaction is fraudulent or not. So in business understanding, we are at a phase where we are trying to identify an opportunity to adopt an AI initiative. So um, we ask ourselves, what is the problem? And the problem is that sometimes our customers uh, allow whether for some reason or other, that their credit card information is compromised and some evil person or actor is trying to make a fraudulent transaction and steal their money. So we have an issue because our customers then call us and they're unhappy because they lost their money and we cannot give it back. So next step is there something we can do about it? Then data understanding is, do we have data that is useful, that contains information that could help us battle this problem that we identified using a data-driven approach? Well, if we are a bank and we have some people who are writing down on historical transactions if they were good or if they were fraudulent, then we can use that to train a supervised model, because all we need is historical data and a particular label that we want to predict for. In this case, whether the transaction is fraudulent or not. This would be a classification model. So then data preparation is just cleaning the data in order for it to be properly organized and do not, so that it doesn't have noise. You would be surprised at the amount of time out of this whole scheme in the screen that is dedicated just to data preparation. Because companies tend to not store data in the most clean of manners. And in order to fit it into models, you really need to spend time like getting it to be pretty and organized and well structured. So once you do have that data in a proper manner, you do modeling, which is training models, which we will look at more in depth in the final talk. That is the next one, about training models and how that looks and how easy it is with today's tools to train models. And then it is evaluation. You've trained some models using some data that you think will help you deal with a challenge. And now it's time to evaluate whether you are happy or not with the performance of those models. This is what we're going to be looking at today, evaluation. This is very useful for project managers because you're not going to be looking at modeling or data preparation much, or even data understanding sometimes. You're going to skip right away from business understanding to then talking to your data scientist in your team. And then the point where you can like reconnect with them and have meaningful conversations is during evaluation, probably, because during evaluation you can add to the subjectivity of, are we okay with these models? Can we use these? Are they good enough? And finally, deployment is, if you're okay with the evaluation, then you can put the model into production. All of what I said is kind of summarized in this screen. So business understanding, what problem do we face? Data understanding, do we have data with structured, useful info? Preparation is, how can we clean this data to be proper for models? Modeling is just training the models. That's the data scientist's favorite part of the job. Evaluation is what we're going to be doing today. And then deployment is the process of more traditional software engineering, putting it into production. I saw a question from Santiago in the chat. How much historical data is needed to train a model? Are we talking about millions or hundreds of records? That's a great question. And it really depends on the level of accuracy that you need from your models. And it really depends on the type of problem that you're facing. If your data in small amounts has enough information already to tell the model something useful about what it's trying to predict. So the more data you have, usually the better, because you have more samples of real life scenarios where the problem you're attacking has already happened. So the more data you have, the better, for sure. But it doesn't necessarily mean that you need millions of examples for a model to perform well. And really, it is very subjective what means okay. Because, for example, classifying a transaction as fraudulent for a bank is quite important, I would say. But even more important is something like classifying whether a patient has a tumor for a diagnostics machine learning process in medicine. And there's tons of regulations that would probably require you to have more extensive data than what you need in a bank to do like an internal implementation that is not going to be necessarily audited externally. And you can even have like a process for yourself where you do like, let's say that you want to do a spam email classifier. It really, like, nobody cares if the model isn't performing really well. You could probably do that with just your own email data and not need to train with someone else's. And that could be just in the hundreds of data points. You don't need millions, of course. Maybe with we haven't talked about the metrics yet, but with a relatively low performance result, you could say that it's good enough for you. And that's part of what we'll be looking at today. So I hope that answered your question. One final thing to anyone here, we're going to be looking at examples of structured data, so classic data that can fit into Excel spreadsheets. But all of this applies as well to unstructured data. So the tumor example is, of course, based on radio images. Classification on images or classification on audio can be evaluated in the same way that we can evaluate models that are classifying like a transaction from a bank. So that's really good as well, that knowing how to talk about model evaluation is useful for both traditional models and newer ones. Small note on deployment, for anyone interested, I'm not going to go in depth in here, but when you talk about deployment, usually in the traditional sense, you're talking about DevOps, which is a process of building infrastructure for the machines that are going to be hosting the software that you're going to be deploying. But when you're deploying machine learning models, especially now with large language models, which there are big challenges about consistent performance. Like you might train a large language model to be like a customer service chatbot for your customers. And then a big challenge is getting it to work consistently, like because users can behave very weirdly to try to make it perform in unexpected ways. It's different enough, the challenges of machine learning models, because of their potential unpredictability, that there's a subfield of DevOps called machine learning ops, which you can investigate if you want. But the main difference with it and DevOps, the traditional one, is that in machine learning operations, you need like monitoring processes that allow you to see in real time if the performance that you originally evaluated with the tools that we're going to see today is degrading. It tends to happen that you train a model and it starts performing well, but over time, its performance begins to degrade. And then you need to use the same tools that we'll be looking at today to evaluate it constantly, like to get automated reports on the performance, and at particular point say like, hey, we should retrain it with more recent data so that it starts performing well again.